Good morning, dear student. Today we will study microcontroller. In previous class, we have studied basic fundamentals of microprocessor. And microcontroller is not nothing. It is a special type of microprocessor. Simply, we can define microcontroller in one line definition is microprocessor with peripherals is called microcontroller. A microprocessor does not has enough memory for program and data storage. Neither it has an input or output devices. When a microprocessor is used to design a system, several other chips are also used to make up a complete system. For many applications, these extra chips imply additional cost and increased size of the product. A standalone microprocessor is not a self-sufficient device. It needs other components like memory and input-output device to make a minimum workable system configuration. In addition to a microprocessor, memory and input-output ports are unavoidable parts of a practically useful system. Most of the times, to have all these components in discrete form and to assemble them on a PCB is not an affordable solution due to following reason. Due to the large size of PCB and discrete component used, physical size of the product is big and therefore it is not handy. Second, to assemble this component, a large size PCB is needed, which results in an enhanced cost of the system. Since discrete components are used, the system is not reliable, nor it is easy to troubleshoot such a system. The overall system cost of a microprocessor-based system built around a CPU, memory, and other peripherals is high as compared to a microcontroller-based system. Design of such PCB need a lots of effort and time. Therefore, the overall product design needs more time. Because of all this difficulty, Intel decided to integrate a microprocessor along with input-output ports and minimum memory in a single package. Therefore, microcontroller is a microprocessor with integrated peripheral. By introducing the microcontroller, the microprocessor-based system design concepts are changed drastically. There are following advantages in designing with microcontrollers. Since the peripherals are integrated into a single chip, the overall system cost is very low. Since the peripherals are integrated with a microprocessor, the system is more reliable. System design needs very little efforts and is easy to troubleshoot and maintain. Product size is small as compared to microprocessor based system, therefore it is very handy. So there are number of popular family of microcontroller which are used in different applications as per their capability, feasibility to perform the desired task. Most common of these are Intel's 8051, Atmel 88951, AVR, and PIC microcontroller. So why these vendors? They are from 4-bit to 32-bit microcontrollers are available. There are various manufacturers who are supplying various type of microcontroller suitable for different applications depending on the power consumption and the available features. They are given below in table. First, various member of Intel 851 family are given. The first family of 8051 is 8031, which contains 128-byte RAM and no on-chip program memory, but it contains two timer, 5 interrupt, and one serial port. And 8032 is the advanced version of 8031. It contains 256-byte on-chip RAM, but no on-chip program memory, and it has one extra counters, and it becomes three counters and six interrupt and one serial port. After then, 8051 came in existence, which contains 128-byte on-chip RAM and 4 KB ROM, two timers, 5 interrupt, and one serial ports. After then, 8051 is the advanced version of 8051, which contains 256-byte on-chip RAM, 8 KB ROM, 3 timers, 6 interrupts, etc. And 8751 128 on-chip RAM, 4 KB on-chip EPROM, 2 timers, 5 interrupts, and 1 serial port. If we talk about second microcontroller 8051, it is the first complete 8-bit microcontroller. It is a name of a family in which the instruction set, pin configuration, architecture are same. Only memory storage capacity is different. Internal EPROM is provided, so it is called one-time programmable. The three criteria in choosing a microcontroller. The first criteria is meeting the computing needs of the task efficiently and cost effectively. Speed, the amount of ROM and RAM, the number of input-output ports and timers, size, packaging, power consumption, easy to upgrade, cost per unit. The second criteria is availability of software development tools like assembler, debuggers, C compilers, emulator, simulator, technical support. Wide availability and reliable sources of the microcontroller. The Intel 8051 is a very popular general purpose microcontroller widely used for small scale embedded system. Many vendors such as Atmel, Philips, Texas Instruments produce microcontroller 51 family microcontroller chips. The 8051 is an 8-bit microcontroller with 8-bit data bus and 16-bit address bus. The 16-bit address bus can address a 64 kilobyte code memory space and separate 64 kilobyte of data memory space. The 8051 has 4 kilo on-chip read-only code memory and 128 bytes of internal random access memory. Besides the internal RAM, the 8051 has various special function registers such as the accumulator, P register, and many other control registers. In 8051, 34 8-bit general purpose register, the ALU perform one 8-bit operation at a time. In 8051, two 16-bit timers, that is T0 and T1, and three internal interrupts, one serial and two external interrupts. And 8051 has also four 8-bit input-output ports. Three of them are dual purpose and one of them used for serial port. You can see here, it is clear from the figure. So first figure in left hand side, this is the microprocessor based system. All the interfacing devices like RAM, ROM, input output ports, timers, serial COM are interconnected with CPU. So it is called microprocessor based system. You can say general purpose microprocessor based system. And on the other hand, the second figure, which contains CPU, RAM, ROM, input output port, timer, serial COM ports in a single IC. You can see here some basic difference between microprocessor and microcontroller. CPU is standalone, RAM, ROM, timers are separate. But in microcontroller, CPU, RAM, ROM, and output timers are all on a single chip. In a microprocessor, second point, designer can decide on the amount of ROM, RAM, and input ports. In second point, in the microcontroller, fixed amount of on-chip ROM, RAM, and input ports. The third point, in microprocessor, it is expensive, high cost. But in case of microcontroller, it is low cost for application in which cost, power, space are critical. Microprocessor is also called general purpose, but it is in case of microcontroller is a single purpose, and microprocessor, if we talk about speed, so high speed. In case of microcontroller, it is a low speed. And some examples of microprocessor like 8085, 8086, and some example of microcontrollers are 8051 and AVR. There are some salient features. The salient features of 8051 microcontrollers are 4 KB on-chip ROM, that is program memory, 128-byte on-chip data memory, 8-bit data bus, 16-bit address bus, 32-bit 32 general purpose register, each of 8-bit, two 60-bit timers, that is 20 and T1, 5 interrupts, 3 internal, 2 external, 4 parallel ports, each of 8 bits, one 60-bit program counter, and one 60-bit data pointer, one 8-bit step pointer, one microsecond instruction cycles. It means it has a 12 MHz crystal frequency, and 8051 has a one full duplex serial communication port. Now we can, we can see here the pin configuration of 8051 microprocessor. So microprocessor 8051 IC contains 40 pin. In figure, you can see here the upper side of this IC, that is notch. So when you see The left hand side of this IC and upper pin is pin number 1, 2, 3, 4, 5, and so on up to 20 pin. So in the left hand side of this IC there are 20 pin. When you move from bottom to right hand side, so this pin number is 21, 22, 23, 24, 25, 26 up to 40 pin. So here you can see pin number 40 always power supply, and you have already observed that right hand side upper pin always BCC. This IC operated plus 5 volt, and pin number from 39 to 32, that is 40. This is the 8-bit port. So it's each pin is assigned a name. For example, pin number 39 assigned port 0, pin number 0, and 38 pin is pin 0, point 1 is, it means pin number 1 of port 0, and and so and so on, like similar P 0.7, it means pin number 7 of port 7. And second port you can see here from pin number 1 to 8, it is called port 1. From pin 1 to 8, this is called port 1. Pin number 1 is P1.0. It means it is a pin number 1, pin number 0 of port 1, and P1.1. So what indicate? Pin number 1 of port 1. P1.2. It means pin number 2 of port 1. In a similar manner, if we talk about P1.7, it means pin number 7 of port 1. So this is the second port assigned through the pin number 1 to 8. And pin number is 9 is restart pin. We talk about port 3. So port 3 are assigned from pin number 10 to 17. So pin number 10 is P3.0. It means pin 0 of port 3. P3.1. It means port 1 of port 3. Pin 3.2. Pin number 2 of port 3, and so on. We can see in this figure there are two crystal pin, that is XLET 1, XLET 2, which is connected to microcontroller pin number 18 and 19. We can hear one more port from pin number 21 to 28, that is called pin number 2. The first pin of pin number 2 is P2.0. It means pin number 0 of port 2. And P2.1, it means pin number 1 of port 2, and so on, etc. And three more pin are assigned in this pin diagram, that is pin number 31, pin number 30, and pin number 29. So pin number 29 is PSEN bar. You can see here PSEN bar. It means programmable status enable, and pin number 30 is address latch enable, and pin number 31 is EA bar external enable. What it's mean? Suppose we have to connect external memory. Until and unless EA bar is 0, then other devices is not connected. And address latch enable is used to activate latch IC, and program status enable is used to activate program memory. You can see here port 0 and port second are used for assigning addresses. Here from pin number 32 to 39. So these are multiplexed pin. It means data as well as address are multiplexed here. And pin and port 3 are used for dual purpose. Like suppose we have to receive data serially through RHD. So this RHD is connected to pin 3.0 at pin number 10. Suppose we have to transfer data serially through TAT pin. So this TAT pin is connected to P3.1, that is pin number 11. And there are two types of interrupt, INT0 and INT1. INT1 is connected to pin number 12 and INT1 is connected to pin number 13. And two more timer pin, that is P3.4 and P3.5 is connected to pin number 14 and 15. Suppose we have to get operation read or write. So pin number 16, that is P3.6, gives write operation, and P3.7, that is pin number 17, which gives read operation. And two crystal pin, that is accelerate 1, accelerate 2 is connected to pin number 18. So these are the description of pin diagram. Here, these are register organization of 8051. In 8051, there are some registers like register A, register B, register R0, register R1, R2, R3, R4, R5, R6, and R7. So these all registers are 8-bit. And two more pointer, that is data pointer and a program control. Both are 16-bit register. And data pointer register can be used as a 8-bit also. So we assign data pointer in as a 8-bit like DPH and DPL. Data pointer higher, data pointer lower. And program counter, these are 16-bit register. Here, memory mapping in 8051. We know very well 8051 contains 128 byte RAM and 4 KB ROM. Suppose we have to connect more data memory and program memory through EA bar and PSEN bar signal. Here, memory mapping of 8051 microcontroller given. From bottom to